right, ladies and gentlemen, let's take a look at today's lesson. There aren't many examples. We're going to take a look at trapezoids, which I think most of you recognize. And so we're going to take a look at their properties. There is a lot of vocabulary, so you're probably going to need to pause here. A trapezoid is a quadrilateral with exactly one pair of parallel sides. It's the one quadrilateral that we're going to study that is not a parallelogram because it only has one pair. So now we're going to talk about specific parts. The base is the two parallel sides. The legs are the non-parallel sides. The base angles of a trapezoid. So when we talk about looking at the base angles of a trapezoid, it was a little difficult to define, so I wanted you to draw a picture of it. We have A, B, C, and D. So when we talk about having a trapezoid there, and we're going to have four angles, and we're going to take a look at those base angles. Angle D and angle C are what we would call base angles. Angle A and angle B are what we call base angles. So base angles come in pairs, and they're the ones that are at the endpoints of those parallel sides. An isosceles trapezoid is a trapezoid with congruent legs. And then the mid-segment of a trapezoid is just the segment that connects the midpoints of the legs. So we're going to take a look at that and those things a little bit later on. Like I said, I would pause here because there's quite a bit of writing to do, and these are all important vocabulary words to have. All right, so we're going to start with another theorem, and it says if an isosceles trapezoid, if a trapezoid is isosceles, then each pair of base angles is congruent. So that relationship that we looked at earlier. So that means angle A is congruent to angle B, and angle C is congruent to angle D. Sorry about that. And if we look at theorem 6.13, that if a trapezoid has a pair of congruent base angles, so now we're going to say, okay, if we know the angles are congruent, then we know it's isosceles. So if angle C is congruent to angle D, that's what we have there, then we know that the sides opposite those are congruent, making it an isosceles trapezoid. So let's take a look at this follow-up. Tell me whether the statement is true for isosceles triangles, isosceles trapezoids, both, or neither. So I'll do the first one with you. Legs are congruent. That is both. Because an isosceles triangle is defined as having two congruent legs, and that's how we define an isosceles trapezoid. So what I want you guys to do is I want you to finish now, and then we'll check those in class. All right, so let's take a look at finding the angle measures of a trapezoid. Really, we're only able to do this if we know it's isosceles or if we are given more than one angle. So we're given angle 50 degrees for angle S, and we know PS and QR are congruent. So since it's an isosceles trapezoid, angle S and angle R are a pair of base angles. And we know that angle R, the measure of that, equals the measure of angle S, so angle R equals 50 degrees. If we use the same side interior angle theorem in the trapezoid, we know because we're cutting a parallel line by a transversal that these angles are going to be supplements. So we know that angle P is equal to 180 minus the 50 degrees, and so that's going to give us 130 degrees. And because angle P and angle Q are also base angles, we know that they are equal to each other. So angle Q is equal to angle P, which we know already equals 130. So we're using this idea of having congruent angles, and then we have these parallel lines, so the same side ones. So these consecutive angles that are non-base angles with each other are supplementary angles. So let's take a look at the checkpoint. We know it's isosceles, so now we can find the other angles. So if it's isosceles, that means these legs are congruent. So that means 100 degrees goes in both of those base angles. So I don't know angle A, I don't know angle B yet, but I do know that angle C is 100 degrees. I know that angle A and angle D are supplements. So I know I can do 180 minus the 100 degrees, and that's going to give me 80 degrees for angle A. I know that angle A and angle B are congruent because this is isosceles. So we have another 180-degree angle. All right? So we're still using this idea of relationships going back to the very beginning of the chapter. And so I want you to do now, and we will check in class. All right, the mid-segment. As you can see, we're seeing some similarities between an isosceles trapezoid and an isosceles triangle. So the length of the mid-segment of a trapezoid is 1/2 times the sum of the bases. All right, so if you can see, they put that in parentheses, so I'm going to write it a little bit differently. It's actually 1/2 of the sum of the bases. So that's what we have in words. So we're going to take the two parallel sides, AD and BC. We're going to add them together first, do what's in parentheses, and then take half of that. Remember, you can multiply by 1/2, or you can divide by 2. Those are the same operation. So let's take a look at how we can use that. We want to find the length of this mid-segment. Really, you're kind of finding the middle. You're finding an average. Take the two bases that you have, add them up, and multiply by 1/2. So we're going to take 1/2 of 8 plus 20, which is half of 28, which is 14. So DG is 14. It's in the middle of these two. We can see that 8 is the short segment. We can see 20 is the long segment. DG is the middle, so it should be a number in between 8 and 20, and 14 makes sense. All right, so our follow-up. In the space on the right, draw any trapezoid TPZD. So I'm going to draw an upside down one. All right, and we have TPZD. And we're going to draw mid-segment NS. All right, it says mark all parallel sides and all congruent segments. All right, so I want to leave you guys with that. You are going to mark the parallel sides and you are going to mark the congruent, so use that tick mark. Mark the congruent with your tick mark segments. All right, so we'll check that in class. All right, so here's our checkpoint. Find the length of MN. MN is just the average of these two, so 8 plus 14. And then I'm going to multiply that by 1/2. So 1/2 times 22. MN is equal to 11. 11 is between 8 and 14, so I feel very confident. All right, your job is to do now. And then we will check in class. Pretty quick lesson here, guys. I know I went a little fast, so you probably have to pause to fill some of this stuff in. But this lesson fits quite nicely from what we know about mid-segments of triangles, and so we're able to apply it to these trapezoids. I hope you guys have a great evening, and we'll see you in class.